Hi everyone, this is Rao Chaturvedi and you are watching Telecom Notes, and today we are discussing about how you camp on a cell. It means we are going for a detailed view over cell acquisition. In between we will have a look over the PSS and SSS, the synchronization signals, and at the end we will have a look about the DL transmission and UL transmission. So let's start then. So how UE camp on a cell? Right now, at the starting, UE is just searching for the frequency to just catch a particular network. So starting from the first point, UE tune to each and every channel that it support and measure RSSI. It just measure the power of each channel. As the UE measure RSSI of each channel, it creates a list of each channel numbers and measure RSSI. It means right now the UE is searching for each and every channel and measure the RSSI, the signal strength of the reference signal of each channel, and it makes a list that how many channels are there with the RSSI value of each and every channel. Coming to the point 2 now, then UE go through that particular list and take out that particular channels having the value greater than the threshold. So then you go through the list and figure out all the channels which shows RSSI value greater than the threshold. Now there are particular set of channels that is having the RSSI value greater than threshold. So if there are multiple frequencies having a RSSI greater than threshold, then on which frequency the device will camp on. So the solution for that is you decode the PCFICH and measure the power and detect physical cell ID PCI for each candidate from step 2. From step 2 means from that particular list having the number of channels greater than having the RSSI greater than threshold, it will take read the PCFICH and take out the PCI for each and every candidate. From the list with successful result from step 3, UE decode master information block for each and every candidate. With this procedure, now UE can make the list of frequency as from the starting list. From the third point, it takes the PCI and now the PLMN also. Based on the USIM as well as the candidate cell table from the step 4, it can figure out that on which particular candidate cell it needs to just camp on and try decoding system information and proceed to the registration process. So now starting with the information how it will just latch to the particular network, starting with the PSS, primary synchronization signal. E node B sends let me take the highlighter. Okay, sorry, okay. So E node B sends the UE PSS, primary synchronization signal. Within this primary synchronization signals are used for time slot and frequency synchronization, and also to get the PCI, that is physical cell ID 012, because PCI has been just created with having a formula PSS plus 3 SSS that I'll just explain you in the further slide. So PSS is a specific physical layer signal that is used for radio frame synchronization. Okay, mapped on 72 active subcarriers centered around the DC subcarrier in slot 0, subframe 0 and slot 10, subframe 5. Here you can have a look. Subframe 0, slot 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and this one is the 10th. So here you can have a look, this one is the 10th and this one is the 0, as it is saying that slot 0 and subframe 0. That means slot 0 and this is subframe 0. This one is the whole subframe 0. And in that particular one, 7th OFDM symbol, you will get the value of PSS. Here also in the 7th OFDM symbol of slot 10 of subframe 5, you will get the value of you will get the PSS, primary synchronization signal. So mapped on 72 active subcarriers centered around the DC subcarrier in slot 2 and slot 12 in TDD. In case of TDD, the PSS has been just placed over slot 2 of subframe 2. That means subframe 2 will be this one, and in this one it will having the slot 2. That means slot 2 means the 0, 1, 2, slot 2, this one. In subframe 2 and slot 2 it will be placed, and for the slot 12 also in subframe 6 it has been just placed at the same location. It is made up of 62 Z of choose sequences. Z of choose sequences are the sequences having the zero correlation with each other. It's having a particular code that are just zero correlated to each other. So for the further slide, for the further videos, I'll just explain the Z of choose sequence also. Used for downlink frame synchronization. One of the critical factors determining is PCI. It helps in taking out the PCI. After that, the eNode B sends UE as the secondary synchronization signal. That is SSS. So SSS is basically used for frame synchronization and to get the physical cell ID group, that is from 1 to 168. So SSS is a specific physical layer signal that is used for radio frame synchronization, mapped to 72 active subcarriers, 6 radio blocks, resource blocks, center around the DC subcarrier in slot 0, subframe 0 and slot 10, subframe 5 in FDD. As the OFDM symbol written over there is the 7th OFDM symbol in case of PSS, and the 6th slot will be used for SSS. So everything remains same. The slot is same, slot 0. Subframe is also same, subframe 0. But in place of 7th OFDM symbol that is having PSS, you have to just go for the 6th OFDM symbol for the SSS, secondary synchronization signal. The sequence of SSS in subframe 0 and one of the subframe 5 are different from each other. It is made up of 62 scrambling sequence based on M sequence. The value is odd indexed resource element, and one of even indexed resource elements is generated by different equation used for downlink frame synchronization. One of the critical factors determining the PCI. Here you can have a look that PCI, physical cell ID, is the combination of PSS and 3SS. That is primary synchronization signal plus 3 multiplied by secondary synchronization signal. So we are having the PCI from 0 to 503. That means just wait, 503. That means total 504 PCIs we are having. 504 PCIs we are having. And how we will get that particular 504 value? As we know, we are having 0 to 167 physical layer cell ID group. If I'll put 167, the highest value, 3 multiplied by 167, I'll get 501. And when I'll add 0, 1 or 2, so I'll get the value 501 PCI, 502 PCI and 503 PCI. So from 0 to 503. How I'll get the PCI 0 now? If the physical layer cell ID group, I'll put the minimum value also. Let's put the minimum value, that is 0. 3 multiplied by 0 is 0. Having the PCI 0. So I'll get the PCI 0. If it so it's having alpha 0, beta 1 and gamma 2. So this type of planning has been just done in case of PCI. And also to take out the PSS value, to get the PSS value, it will be the remainder of PCI divided by 3. In case of SSS also, it's percent of PCI divided by 3. After that, eNodeB sends the DLRS downlink reference signal for the channel estimation and measurement. Measurement means here is as we are talking about the reference signal, it is having RSRP, RSSI, RSRQ, and for the channel estimation, it will read the multiple channels further, and it will get the channel estimation that where that particular data has been just arrived for a particular UE. After that, it reads PBCH, physical broadcast channel, having master information block, that is downlink system bandwidth. It will get from the master information block that particular information is downlink system bandwidth and PH configuration. So the challenge over here is the PBCH contains only the master information block. The system information blocks are on PDSCH, physical downlink shared channel. So how that particular SIPs has been just read by your UE. So the problem is the UE should read PDSCH, but it doesn't know which resource blocks are reserved for it, where are they placed in time and frequency. So for the solution we are having PCFICH. Let's put it number 1. The PCFICH physical control format indicated channel that indicates the size of PDCCH. Put the number 2 in case of PDCCH, that indicates the size of PDCCH physical downlink control channel, and the PDCCH is indicating that which resource blocks are scheduled and where are they located. That means from PCFICH we'll get to know the size of PDCCH as it covers up to the maximum 3 symbols from 0, 1, 2. It can just from 1, 2 and 3 it can carry the symbols differently. So PCFICH, that is having control format indicator, will tell that where that particular PDCCH value you will get for that particular UE. And after reaching to when you are just reading that particular PDCCH, you will get that where, at what location you will get that particular data for your UE placed on PDSCH, physical downlink shared channel. So to read PDCCH you will get PCFICH, and to read PDSCH you will get PDCCH. So coming to PCFICH, PDCCH and PDSCH now. PCFICH, physical control format indicator channel, it tells you how many OFDM symbols, that is 1, 2 and 3 in the beginning of the subframe are of PDCCH, that how much location PDCCH has just covered up for the particular UE. Now coming to PDCCH, physical downlink control channel, that will give you the resource allocation for PDSCH for your UE. Now in case of PDSCH, physical downlink shared channel, SIBS, cell global ID, and it will tell you about the parameters for cell selection and reselection. So after this procedure the UE will go for cell reselection as well as cell selection. UE. Hey viewers, I found a suitable cell now. So it's been searching for cell selection and reselection. So it found a suitable cell. Now what I have to do next to start DLUL transmission? So what it has to do is it has to go for the initial attach procedure now. Okay, for initial attach procedure, starting from the PRACH, that is random access channel, physical random access channel. So UE sends the PRACH preamble to the eNode B. UE transmit a specific pattern. That particular pattern is also Z of 2 sequence, so that they are just having zero correlation with the other code. So UE transmit a specific pattern, and this specific pattern is called as signature. In each LT cell, total 64 preamble signatures are available, and UE select randomly one of these signatures. So out of 64 preamble, it randomly take out any preamble and go for accessing or go for asking the network to just get a dedicated resource. So in detail of the random access procedure as well as the contention resolution, we'll discuss in that particular video of random access procedure. Now coming further, when UE sends the preamble to the eNode B, then eNode B sends again the PCFICH channel first, so that it can just decode PDCCH, and after PDCCH it will decode the PDSCH that contains the random access response ID of the received preamble and contains CRNTI. So random access procedure is done. Now what's next? The next steps will be RRC connection establishment, registration to the network, and UECN signaling, that is attach. Coming to the DL transmission now. Suppose eNode B sends DL reference signal having the channel estimation, measurement also, and based on that particular measurement it will take the CQI also on channel PUSCH. So eNode B sends DLRS to UE, and UE sends PUCCH, physical uplink control channel. The CQI based on downlink reference signal measurements. So UE sends the CQI value based on the downlink reference signal measurements. That means RSRP, RSRQ, RSSI. After that, again on the PCFICH, physical control format indicator channel, how many symbols 1, 2, 3 in the beginning of the subframe are for PDCCH. From PCFICH, UE decodes PDCCH, DL assignment of for PDSCH, that what's the modulation and coding scheme and what are the resource blocks having that information to your particular UE. So from PDCCH it again decodes PDSCH, physical downlink shared channel, that contains the user data initial transmission. After that UE sends the UE to the eNode B, PUCCH, physical uplink control channel, having the acknowledgement ACK/NAC for HARQ process. The eNode B sends PDSCH, physical downlink shared channel, having the user data again. So now the UE is downloading that particular user data having the PDSCH, physical downlink shared channel. So this is the DL transmission, that how UE starts downloading a particular file from the network. Now coming to the UL transmission. In case of UL transmission, PUCCH, physical uplink control channel, or PUSCH sends the UE scheduling request from UE to eNode B. After that, UE sends uplink sounding reference signal used by Node B for channel dependent scheduling. Then UE sends UL demodulation reference signal, that is for uplink channel estimation and demodulation at the eNode B side. After that, eNode B sends PDCCH, physical downlink control channel, having the uplink grant, that means the capacity allotted to that particular UE. After that, UE sends the eNode B PUSCH, physical uplink shared channel, that is the user data initial transmission. For the acknowledgement, it sends PHICH, that is physical HARQ indicator channel, eNode B sends the ACK or NAC to UE regarding the PUSCH, that is the user data initial transmission, and after that the uplink process has been just started. So on PUSCH, user data has been just uploaded from UE to eNode B now. So that's all from my side. Thanks for watching the video. Let me know if you are having any query or any suggestions. Thank you.